Okay. So good evening, good afternoon, everyone. Welcome to Abhyas, and this is the fourth lecture. So Rohit, you are always on time. Okay. So this is the fourth lecture. First lecture we did material science. Yeah, good morning. Sorry, I made a mistake. Second and third lecture, we did some beautiful problems from metal forming 1 and metal forming 2. And this particular lecture and the next lecture, we are going to see metrology. Purposefully, we have given 2 days for metrology and also metal forming, because in GATE, these 2 topics are very, very important. Okay, now, so entire production, as I told you, approximately 18 marks question comes. And from metal forming and metrology put together, you will get 6 to 7 marks just from these 2 topics. Just from these 2 topics. So that's the reason we have taken 2 lectures of metal forming. And now there are 2 dedicated lectures will be for metrology. So in the first lecture of metrology, I'm going to cover these 2 topics: limits, fits, and tolerances, and the tolerancing, including the gauge design. In the second lecture of metrology, I am going to cover surface finish, screw thread metrology, little bit comparator, and then interferometry. Interferometry, very beautiful question comes in GATE, interferometry, but frequently questions will be the screw thread metrology and surface finish. So interferometry, surface finish, screw thread metrology, and little bit alignment test we will be going to do in the second lecture. And please remember that Saturday, Sunday, there is no Abhyas class. We will have on Monday. So this is the credentials. Some of you may be new. So these are my credentials. So as usual, all those who are champions, they are there. So I have something for you. I will let you know, especially Rohit, Naved, Karmakar, Vishal, Kushwaha, 96. Okay, na? So I will tell you during the lecture what you have to do. There are some more people that I am waiting for. So let us start the questions. When I was teaching crash course, I told you that especially in the limits, fits, and tolerances, no matter how the simple question is, you should make the fit diagram. You should make the fit diagram. So let us start. Today also I have arranged in the same way. First 4, yesterday I have taken the easy questions at the end. But today I am taking the easy questions at the beginning. So first 4 or 5 questions are very, very easy. Then I will increase the difficulty level. Okay, na? So no matter how easy question looks like, I will make the fit diagram. Okay. Which one of the following represents the type of fit for hole and shaft? We are given that hole is 50, lower limit 0, upper limit is 0.04. So let us make the fit diagram. 50 is the basic size, and this is 0.04. This is your hole. Now for shaft, of course basic size is same. 0.041 is the lower limit. So the tolerance will be here. Lower limit is 0.041. Upper limit is 0.060. Upper limit is 0.04. This is the fit diagram. So now which type of fit it is? Shaft is totally above the hole. So it is a interference fit. See, first 3-4 questions are very, very easy. Yeah, very good disclaimer. Yeah, Naveed, thank you very much. That's what you remember that. Okay, na? Make no matter how simple the question looks like, do not consider yourself champion. Make the fit diagram. I told you during the crash course, and here you are. Thanks for reminding. Because the questions 100% answer will be correct, but in the hurry burry you will make it wrong. In the hurry burry you will make it wrong. So D is the interference fit. Now what I want all of you, those who are, because in our team we discussed yesterday a lot. Yeah, DP, I know DPP, actually we are getting it. See, and there are two tabs. Under one tab the DPPs are available. You know, all our faculties from mechanical, we discussed yesterday, and what we decided basically, that after Abhyas, or let us say crash course, we will take your problems personally. We have very dedicated people from minimum at least 6 or 7 years of experience, and they are perfect to guide all of you. So what I want from you, okay, those who are seeing this crash, this one Abhyas course, especially those who are attending my class today, what I want, you write your phone number, your email ID, your which college you are working. Okay, which college you are basically studying your third year, which year you are in, and this detail you send it to me. SWADESH_108 So of course we have a Telegram channel. Through that I will be taking care of your taking care of your doubts, all the faculties. Especially I am going to assign myself a certain period of time. But especially I told you there are some champions here, 7 or 8 champions. Not only champions, other people also we would like to support. So before GATE examination, you should be confident that not even a single problem you have before entering into the examination hall. For that purpose, we are deciding something, all our faculties, our team. So you send it to me, I will form a database, and let us see how we can help you. Okay, so once again, as the Naveed told you, that certain things we have to remember here. Number one, you make the fit diagram. You make the fit diagram, no matter how easy question is. Number two, answer should be correct up to 3 decimal places. Do not round off. Okay, na? Yeah. Second question, how many grades of tolerances does the ISO system of limits and fits specify? So as I told you, that grade of tolerances, when the system was developed, of course the answer is very easy, but I want to give you some background. Why the tolerances are provided? Because it is not possible to make the product exactly. So when the system was established, there were 16 grades. There were 16 grades originally. But later on, slip gauges were invented. So to compare the tolerances on the slip gauges, 2 more grades were added. Similar to the 0th law of thermodynamics. Technically speaking, 0th law should have come before, but 1st law was already there in the system. So what people said? 0th law. Same thing is exactly here. IT1 was there, but 2 more precise grades were required to compare the slip gauges. So 2 more, IT0 and IT01. These 2 grades were added. Just to compare the slip gauges and other precise measurement systems. So there are presently 18 grade of tolerances. Answer is C. There are presently 18 grade of tolerances. 18 grade of tolerances, and some of you are saying no, not 25 grades of tolerances. There are 25 different types of fundamental deviations. And what is a fundamental deviation? How far, suppose this is the zero line, how far tolerance zone is situated from the basic size, either this one or this one. So there are 25 different types of fundamental deviation, but grade of tolerance as of now are 18. Previously was 16, but as of now there are 18. So answer is C. See, I'm telling you, all the question is easy, but see, some of the champions, they made it wrong. You are champions, but because you are not thinking properly, you are hitting the wrong answer. See the chat box. Correct, na? Everybody is okay. That is the reason I'm telling you, in metrology, you should always be attentive. You should always be attentive. What is given in the question? You should have a cool head. Okay? So first 4 or 5 questions are very easy, but still I want you to, go through it. Once again, whatever I send by mail ID, if not all, at least the champions, the 8 or 9 champions are there. I want you to write your name, some name, phone number, which college you are studying, something like some information, okay? Then I will compile it a Excel sheet. Idea is that our team, mechanical team, would like to help you all the way till you enter into the GATE examination hall. So that's the reason, yesterday we discussed with our team. So that's the reason we are requesting. Question number 3. Can you read question number 3? Can you read question number 3? The most appropriate reason for specifying grades or tolerances in ISO system. Especially for gauges. Especially for gauges. Limit gauges, there are 3 systems: workshop, inspection, and ISO. There are 3 systems now. So why we follow ISO system? Specifically for gauges. To avoid the conflict between the workshop and the inspection department. For convenience. For ease of manufacture of parts. To help quality personnel accept more components. Yeah, what is the answer? Anybody, any champion? What is the answer? What is the answer? Tell me, at least suggestions from you. There are 3 systems in especially gauge design: workshop, inspection, and ISO. Generally, we follow ISO system. Why we follow ISO system? Anybody from you? Nishant Pathak, application issue, we have one person in mechanical. You write it to me, I will connect it to you. Connect it to him. His name is Kuldeep Rathor. He will help you because he is dealing with all these things. Okay, na? Just write mail to me and give your number. I will forward it to him. Okay, Pavan D, Naved C. These are good questions because although theory looks easy, but our champions are getting confused. Correct? Our champions are getting confused. That there are limit gauges. There are limit gauges. Plug, ring, go, no go. We understand, na? Now to define the tolerances, there are 3 systems. Workshop, inspection, and ISO. We follow ISO. Some of your Karmakar is saying all champions. Okay, Vishal A, Suresh A, Adesh A. This answer is correct. Answer is A. I will tell you. I will tell you the reason. Okay, very good. Tripathi D. Anyway, Tripathi given very good answers yesterday. Anyway, you hear me now. I am making, let us say, only for whole. This is the whole. For whole, we will design plug gauges. For whole, we will design plug gauges. So if it is workshop gauge, tolerances will be like this. And what fundamental says, because tolerances are towards the work tolerance. This is the work tolerance now. Because tolerances of gauges are towards work tolerances, some of the good parts will be treated as bad parts. There is an error. This is basically workshop department. Inspection department says that tolerances will be away from the work tolerance. This is the inspection. This is the workshop. Now, if you follow the inspection department gauges, some of the bad parts will be treated as good parts. See, on this gauge design, I have one YouTube lecture, half an hour lecture, detailed lecture. Just search. So there, whatever I am speaking, I have discussed the fundamentals there. So by adopting the inspection department, some of the bad parts will be treated as good parts. So now in the company, there is a lot of conflict between the workshop department and the inspection department. So to have an agreement, there are ISO gauges. In ISO gauge, go is taken from the workshop and the no-go is taken from the inspection. To avoid this conflict, go is taken from the workshop and the no-go is taken from the inspection. To avoid that conflict, we generally prefer ISO system. Okay, so here A was the correct answer. A was the correct answer. Okay, now everybody is okay. Rohit ki googly hogi thodi si, because he was expecting that always my answers are correct. Sometimes champions are also give the wrong answer. For example, Rohit Sharma, sometimes he is also getting clean bowled on a duck. Same thing happens with our champions today. Sometimes our champions like Virat Kohli, he is also getting out on a duck. Rohit Sharma also getting out on duck. But they are scoring centuries sometimes. Very good, very good, very good. Question number 4. Question number 4. In a shaft basis system, the upper deviation of the size of shaft is, what is the answer? Question number 4. What is the answer in the question number 4? What is the answer in the question number 4? Very good, very good. Adesh, very good. Anybody else? Yeah, Vishal, very good, very good. Kushwaha, very good. Keshav Rathor. Oh, sometime Hardik Pandya. Or is question ko kar lo. Very good. Karmakar Tripathi Rohit. So what is the shaft basis system? This is the zero line and this is the shaft. So this is the shaft basis system. Very good, very good. Now everybody is correct in this. So it will be 0. Fundamental deviation is 0. H type of shaft. Fundamental deviation is 0. So answer will be D. So answer will be D. So these are easy questions. So we have designed these questions to just basically, your screw should be little loose. Okay, na? And some fundamentals you can recollect. So answer is D. Easy question, easy question. Very good. One mistake can replace you from IIT to NIT. But don't worry. Yes, I told you, our team will help you to clear your doubt till the last day. So that is the reason we are having something in mind. That's the reason I requested you certain things, okay na? And Telegram channel is there. So one mistake, you cannot afford to do any mistake in GATE, because suppose 2 marks question. If it's correct, +2. Wrong, negative marks is also there. Not only lose 2 marks, but negative also. So your rank will be drastically changed just by one mistake. So along with the hard work, there are 3 things you have to do. Your hard work, number 1. Your hard work. Number 2, our support. Whatever questions are having, we will support you. Number 3, get up in the morning and for 15-20 minutes, remember God. Okay, na? So these 3 things will help you to crack very good rank. Okay, na? Yeah. Question number 5. In the hole and the shaft pair designated 40H7D9, the number 7 and 9 indicate. So H, it's a hole. D type of shaft. 7 means this is IT7, and 9 means this is IT9. So now, which option is correct here? Which option is correct here? Yeah, very good, very good. This was a easy cake. This particular question was a easy cake. This particular question was a easy cake for all of you. Very good. So I'm quickly moving forward because it was an easy thing. Yeah. Now, very, very fundamental question. Question number 6. Very, very fundamental question. You know, I request you one thing. When you are answering, just write the question number. Because for some student, net is slow. So whenever I get their answer, it will be little late. So give the question number before giving the answer. Now, question number 6. Which of the following is not true for the hole and shaft basis systems? Which of the true is not true? Which of the following is not true for hole and shaft basis system? 6th. Give me the answer by giving the question number. By giving the question number. I'm just standing on the side so that you can clearly see the screen. Out of these 4, 3 statements are correct and 1 statement is wrong. You have to identify the wrong statement. You have to identify the wrong statement out of these 4. Yeah. Hole basis system is generally preferred over the shaft basis system. B. Shaft basis system can be used when products are made from bright drawn bars. Choice of the system depends upon nature of the product. D. In hole basis system, allowances are applied to the hole. There is one statement wrong and then you can easily identify that. There is one, yeah, oh my God, everybody is correct. See, this is 100% wrong. This option D is 100% wrong because what is allowance? Suppose this is your hole and this is the shaft. So allowance is always difference in the maximum material limit of hole and shaft. Allowance is always for a fit. Allowance is always for a fit, not individual hole or individual shaft. Allowance is always for a fit, not for individual hole or individual shaft. But what D option is telling? In hole based system, allowances are applied to the hole? No. Allowance is always for a fit. Fit means a combination of hole and shaft. allowances are always for a combination of hole and shaft, not for individual hole or individual shaft. So D statement is wrong. So answer is D. Most of you have given the correct answer. Most of you have given the correct answer. Yeah. Question number 7, again a brainstorming question. I want you to give the correct answer. What is the actual deviation? In metrology, whenever we use this term deviation, what is the exactly meaning of that? Tell me what are A, B, C, D. I'm just standing on the side so that you can give the answer clearly. Huh? What is exactly the deviation? Think over it before hitting the answer on the chat box. Think over it before giving the answer in the chat box. Think over it before giving the answer in the chat box. Seventh. No. Only one answer is correct as of now. Oh, 2. Noora Fatehi and Rishabh, your answers are correct. Noora Fatehi. Yeah, Vishal. Yeah, Tripathi. C. Suppose this is the normal distribution. So this is the normal distribution of any machine producing either hole or shaft. Let us say this is my targeted value. This is my targeted value, but the machine mode of normal distribution is slightly off. This is called deviation. This is called deviation. So even the crash course, I have given you some idea that the machine environment follows a normal distribution. So what is the mean or mode of normal distribution? And what is exactly your targeted value? That difference is called some spam was there, you know. Our backend team is very active today. Okay, na? Anyway, it's really, there are too much negative minded people. So, understood what is the meaning of deviation once again, because I was seeing the chat box, something was happening. So, our backend team has removed that fellow. So, anyway, machine environment follows a normal distribution. So what is the mean or mode of that normal distribution? And what is exactly your targeted value? That difference is called deviation, and the answer is B. Understand? Very good, very good. I really appreciate the students, those who hit the correct answer without my help. It's a B. Everybody understood? It was a very good problem. In fact, this problem was taken by Rohit. Rohit is basically, our colleague, the person who helps us to basically me to put the problems together. This idea is taken from previous gate problems. If you see approximately 90s and up to 2010 gate problem, very, very good conceptual problem you will get from metrology. So this idea is taken from that, because I remember doing such type of problems in 2003s. Okay, very good. So I hope it is correct. This is the last easy question. 8th question, very good. Now you let me know which answer you will hit. Which of the following is true for plug gauges? So out of these 4, 1 statement is correct and 3 statements are wrong. You have to identify the correct statement. You have to identify the correct statement. I am standing on the side so that you don't have any problem in looking at it. looking at the problem, you don't have any problems. That is the reason I am standing on the side. Okay, I will wait for the answer. You be peaceful, even if it is 1 minute more, but still you should give me the correct answer. I will explain to you after 1 minute. Let us say I will wait for the answers. I will wait for the answers. Eighth, very good. Some answer already started popping up. Yeah, yeah, correct. Anybody else? Rishabh, Pavan, Suresh answers I am already able to see. Anybody else? Rohit, Vishal, everybody is telling the same answer, and in fact it's the correct answer. B. B is the correct answer. Very good. So plug gauges, size difference between the go and no go plug gauges is equal to the tolerance of the tested shaft or hole. This is the only correct statement. Very good. So practically without fail, all of you are giving the same answer, and in fact is the correct one. So there is no dispute in the answer. There is no dispute in the answer. So everybody understand. Okay, na? Very good. Very good. So up to 8th problem, these were very, very easy problem. Now from 9th problem onwards, I'm increasing the difficulty level little bit, not too much, but now these are numericals. And one more thing I would like to tell you. Suppose the problem looks big in metrology. Suppose the problem looks big in metrology. You have to see very, very carefully. You don't have to even solve it. Just by looking at the options, you will be able to hit the answer. So we did some of the problems in crash course. Okay, so please don't forget that one. Okay. Question number 9. Design the general type of go and no go gauges. General means ISO gauge. General means ISO gauge for a 50 millimeter shaft and hole pair designated 40 H8D9. 40 H8D9. So as the information is given, I would like to plot the fit diagram. This is IT8, basic size is 40, and D will be somewhere here, epsilon D, and this is IT9. Okay, and here there are plug gauges and there are ring gauges. So now, yeah, what is the other information? These things we know very well. I is equals to 0.45 d raised to power 1 by 3 plus 0.001 d. Yeah, we know that very well. 40 millimeter lies in the diameter range of, oh, this is the one. D1, D2. So D is nothing but under root D1, D2. What I told you in the normal lectures, that in the fundamental tolerance and the fundamental deviation, fundamental tolerance and fundamental deviation, whatever D is there, it is the geometric mean diameter. It's the geometric mean diameter and not the basic size. So step is given, you calculate the geometric mean diameter. IT8 is 25 and 40i. So this is 25i and this is 40i. Okay, so everything is considered. Consider wear allowance to be 10% of the gauge tolerance in this question, and the gauge tolerance is 10% of the work tolerance. You have to be little careful. Sometimes, yeah, everybody is careful, huh? Because this question is slightly different. Although looks easy, but it's slightly different. I want to elaborate little bit here. This question says, compulsory you have to take the wear allowance. Compulsory you have to take the wear allowance. Generally what we do, when the work tolerance, everybody should hear me for 2 minutes, leave everything, just hear me. For 2 minutes, leave everything and just hear me. Question we will do later. I am not worried about solving the question, but I am worried about that all of you should understand what is the fundamental I am telling you. Okay, now? Generally, in the questions of the gauge design, we neglect the wear allowance if the hole tolerance and the shaft tolerance are less than 0.1. That's what we do, right? But suppose we have to see the question very carefully. If the question says that you have to consider the wear allowance, we have to consider even if the work tolerance is less than 0.1. Once again, even if the work tolerance is less than 0.1, if the question asks, we have to consider the wear allowance. Is that okay with everybody? Please do not forget this one. Please do not forget this one. Okay, that's the reason I'm emphasizing too much. Now it's a ISO gauge. So here will be go, here will be no go for plug. Ring, this will be go, and this will be no go for ring. So this is the wear allowance. Wear allowance we give only to the go gauge. Wear allowance we give only to the go gauge, and this is the no go gauge. Why we give wear allowance to only the go gauge? Because it is the go gauge only that is moving inside and outside the hole. So there will be wear on the go gauge. But the no-go gauge is not covering the complete working length. So wear allowance we will not give to the no-go gauge. Wear allowance we will give only to the go gauge. And here, this is go, and this is no-go. So now see, ring, no-go minimum, no-go maximum. Ring, go minimum size, go maximum size. Plug gauge, go minimum size, maximum size. Plug no go, minimum size, maximum size. So I want this type of chart. Plug, go, no go. Start doing maximum and minimum. Start doing, because whatever procedure I told you, na, start doing quickly so that we can get the answer quickly. Now ring, go, no go, maximum size, minimum size, maximum size, and minimum size. And we know that I is equals to 0.45 d raised to power 1 by 3 plus 0.001 d. And the fundamental deviation formula is also there, minus 16 d raised to power 0.44. This is the fundamental deviation. The reason I have incorporated this problem is because in Abhyas batch, some students will be new. So I want to cover the entire width of the syllabus with the help of questions. Some of you are basically coming from my crash course, but some students may be new. So they should be also in a position to cover the entire width of syllabus. That is the reason I have incorporated this problem. Okay, now? So can you give me the complete table? Can you give me the complete table? So some of the things I can tell you. This is 0.039. And epsilon d is 0.08. And the 40i is 0.063. These are the, I have solved and presented the answer here. I will give a pause for 1 minute. I will give a pause for 1 minute. So that you can complete. Okay. All right. All right. So those who are not our crash course students, those who are new students, I will change the color. Let us say this one. This is the work tolerance 0.039. So this will be 0.0039 because gauge tolerance is 1/10 of the work tolerance. So this will also be 0.0039. And the wear allowance is 1/10 of the gauge tolerance. Gauge tolerance is 1/10 of the work tolerance, and the wear allowance is 1/10 of the gauge tolerance. So this wear allowance will be 0.00039. Okay, na? So we have to consider. Yeah, very good. Suresh Banut, you are also one of the champion. Banut, still I remember. Okay. Now this is 0.063. This is 0.063. So this will be 0.0063. This will be 0.0063. And this wear allowance will be 1/10 of this. 0.00063. Again, once I would like to emphasize that generally the wear allowance is given, not given when the work tolerance is less than 0.1. In both the cases, work tolerance is less than 0.1. But if the question says that you have to provide wear allowance, then you have to consider. And the wear allowance will be 100 times of the work tolerance. So this is 100 times of this. This is 100 times of this. So now keep on adding, subtracting. 40 plus this is the minimum size of go plug gauge. So keep on adding and subtracting. I am writing this table because I have solved this one. Color is yellow. Okay. 40.0042, 40.0003, 40.0429. Just match the answers. 40.039. Now ring 39.9193 39.9130, 39.857, 39. So this is the complete chart you should be getting. This is the complete chart you should be getting. And I want those who are Abhyas batch student, those who are my Abhyas batch student, whether new or old means those who are coming from the crash course, later on they will be seeing this video. So especially those who are new students, I want all of them to complete this problem. Because if this problem is complete, I personally feel that you will not have difficulty in hitting any problem, any numericals of gauge design. You will not have problem in hitting any problem of gauge design. Okay? Any problem of the gauge design. And whenever you are finished, please let me know in the chat box. I will move forward. Whenever you are finished, please let me know in the chat box. I will move forward. I will move forward whenever you are finished. Okay? Now can you tell that? Can you write in the chat box whether everything is okay? And if you have finished the problem and whether all these answers are correct. If all these answers are correct, can you write whether plug gauge, ring gauge, go, no go, go, no go, whether all these answers are correct or not? Please tell me in the chat box whether all these answers are correct or not. Whether all these answers, minimum, maximum, all these answers are correct or no. Please let me know. Then I will move forward. If it is correct, I will move forward. Once everything is correct, I will move forward. Okay, good. Okay, good, good. Very good, very good. Very good. So it was a numerical. Always remember limits, fits, tolerances, and the gauge design. Numericals are easy. But while answering the questions, your head should be cool. While answering the questions, your head should be cool. So many students says that they have finished it. So I will move forward. Okay, na? I will move forward. If you see carefully in the metal forming, in actual gate exam, questions are very, very difficult. So that's the reason I have taken a great difficulty level in Abhyas 1 and 2 for metal forming. For metrology, what is my focus, especially in the first lecture? My focus is that fundamentals should be clear and you should not do any mistakes while answering the question. You should not do any mistake because calculations are easy. Okay. Next question. It's an easy one. It's a P by Q. It's a gate P by Q. It's a gate P by Q. It's a P by Q. Go and no go plug gauge is to be designed for measuring a hole of a nominal diameter of 25 millimeter. So 25 millimeter with a hole tolerance of plus minus 0.015. So this is your 0.015. It's a P by Q. So how much is the width of tolerance zone? 0.03. And it's a hole. It's a hole. Okay, na? Considering 10% of work tolerance to be the gauge tolerance. We know that very well. We know this very well. Ayyo, kya ho raha hai? Oh, all of you are able to hear me. Can you let me know in the chat box whether everybody is able to hear me? Because I feel there was little trip. Now, whether everybody is able to hear me, let me know in the chat box whether everybody is able to hear me now. Yeah, it was buffering because I was able to see here in my screen. So whatever your reception, one reception I am able to see in front. So there was some issue for some time. Now everybody is okay now. Can just confirm me in the chat box. Everybody is okay now. Audio and video. It was buffering for some time. I was able to see in my screen. That is the reason I stopped for some time. Okay, now good, good. Now it's okay. Yeah, good. So it's a PYQ question. Width of tolerance zone is 0.3. So gauge tolerance will be 1/10 of work tolerance. So it will be 0.003. Now it's a hole. And work tolerance is less than 0.1. So I will not be providing the wear allowance. So this is the go. And this is the not go. So this is 0.003. Now the question is asking about the unilateral tolerancing system. Unilateral tolerancing. So what you have to do, you shift the basic size here. Shift the basic size here. So basic size will be 25 minus 0.015. Comes out to be 24.985. So now 24.985, we are talking about go, and this is 0.003. So how we can define this go size? 24.985 plus 0 plus 0.003. That's the way we will define. Correct, na? See, that's the way we will define. That is the way we will define. Okay. It's a PYQ. It's a PYQ. It's a PYQ problem. It's a PYQ problem. It's a PYQ problem. And very important PYQ. It's a very important PYQ. If you remember, similar type of problem we discussed in crash course. Because the nature of the problem is important. That's the reason I have added in the crash course also. Because I don't want this problem to be missed by anyone. I don't want this problem to be missed by anyone. Okay, na? So D, everybody is getting D. Okay. Yeah. Question number 11. Question number 11. Question number 11. I want you to give me the answer. I want you to give me the answer. Please, Banot, please write the question number before giving the answer, because sometimes, some students, the the band width is low. So technically speaking, I am doing here next problem, you are giving the answer of the last problem. So this is the question, I am on the side and I want you to give me the answer for this one. I want you to give me the answer for this one. Make the fit diagram before answering. Make the fit diagram before answering. Tolerances for hole and shaft. This is the hole and this is the shaft. So make the fit diagram. Hole and this is 0.02. And the shaft, this is the shaft and this is 0.05, this is 0.08. So remaining is 0.03. So based on the data, I have plotted the fit diagram. What is the maximum and minimum clearance? Minimum clearance is 0.05 and this is the maximum clearance 0.08 plus 0.02. It's a clearance fit. Is that okay with everybody? Very good, very good, very good answers. Tolerance on shaft and hole. Tolerance on shaft is 0.03. Tolerance on hole is 0.0t. Can you give me the allowance? Can you give me the allowance? Very good, very good. All of you are doing well. I want you to give me the allowance value. What is the value of allowance? What is the value of allowance? What is the value of allowance? Yeah, very good, very good. Yeah. What is the value of allowance? What is the value of allowance? So what I told you, allowance is the difference in the maximum material limit of hole and shaft. Yeah, all of you are correct. Allowance is the difference in the maximum material limit of hole and shaft. What is exactly this maximum material limit? Once again, I will tell you for the crash course student, because some students, those who are not crash course, they are in the Abhyas. So for their benefit, I will again speak. It's a very, very important point. Many students are having confusion. What is the maximum material limit and what is the minimum material limit? Many students are having confusion. See, the dimension for which the weight is more, the dimension for which the weight is more is called maximum material limit. The dimension for which the weight is more is called maximum material limit. So the larger diameter of shaft will have more weight, correct na? Because smaller diameter means we are removing material further. So larger upper limit of shaft will have more weight. And if the hole size is smaller, it will have more weight. If the hole size is smaller, it will have more weight. So upper limit of shaft and the lower limit of hole are called maximum material limit. So for hole, Maximum, this is the 50, na? Maximum material limit is 50. And for the shaft, this one, how much? 50 minus 0.05. So it's a 49.95 is the maximum material limit. Once again, the limit at which hole or shaft weight is more is called the maximum material limit. And the limit for which its weight is less is called minimum material limit. So understood now what is the maximum material limit? It's very, very important. Many students, they ask question even after repeating 2-3 times, "Arey sir, what is this maximum material limit?" Once again, both hole and shaft will have minimum size or maximum size. The size at which its weight is more is called maximum material limit. And the size for which its weight is less, it's called minimum material limit. So allowance is always for an assembly. It is a difference in the maximum material limit of hole or shaft. So in the clearance fit, it is minimum clearance, and for interference, it is a maximum interference. Whether it's a clearance fit, transition fit, or interference fit, allowance will always be difference in the maximum material limit of hole and shaft. Allowance will always be the difference between the maximum material limit of hole and shaft. So many times I repeat it because it's a very important concept. So all the answers I have given you here, and I think most of the answers are matching with yours. Very good. Most of the answers are matching with yours. Very good. Okay. Next question. This is a really very beautiful question. Very beautiful question. Read the question. And I will solve this question, okay na? I will be solving this question, so you don't have to worry. This is a slightly different question, okay na? Here we are not machining, we are welding. So, yeah. 3-component welded cylindrical assembly is shown below. So once again, I am explaining the question because the class notes in the PDF form, anyway you will get it. So you don't have to basically copy it, anyway you will get it. I am explaining the question. Okay na? There is a P part, x1, and x1 mean length is this, and the tolerance is 1.2. For x1 part, means P, basic size is 18, tolerance is plus minus 1, equally bilateral, 1.2. Okay na? For Q part, basic size is 32, tolerance is 1.0. R, it's 24, plus minus 1.5, plus minus 1.5. Okay, all right, Naveed. Thank you. No problem. Life is full of emergencies, actually. Okay, no problem. Okay. See the sentence here. The mean length of the 3 components and their respective tolerances are given in the table below. So PQR tolerances are given, mean length is given. Okay. Question is, see this question very, very carefully. Assuming a normal distribution for the individual component dimensions. Individually you have made, and now you are welding it. The natural tolerance limit for the length y is the overall length. or the assembly is this one. If such type of problems are given, please don't give answer. I will solve. I will solve. You are making the 3 components separately and then welding it, and now see how much is the overall tolerance of the component, and each component will have a complete normal distribution. Please have a relax, drink little water so that your mind is peaceful. I am not expecting any answer in the chat box. I am not expecting any answer in the chat box. I want all of you to please hear. I want all of you to please hear what I am saying. In metrology, whatever tolerances you see, these tolerances are portion of probabilities of normal distribution. See, if I want to solve in 30 seconds, I can solve this and you can mug up the answer. That is not my target. I want to teach you some background. Suppose some different problem comes, how will you handle? So I want to teach you the background. Okay, na? Oh, there is no space. Okay. Whatever tolerances you see in metrology, these are portion of probabilities of normal distribution. Like there is a topic called selective assembly. There is a topic called selective assemblies. You know why the selective assemblies came into picture? How the selective assemblies came into picture? Because my desired tolerances are much smaller than machine process capability. My desired tolerances are much smaller than the process capability. 6 sigma. This is the process capability, na? This is the process capability. And let us say desired tolerance by the consumer is 1/4 of process capability. Desired tolerance by the consumer is 1/4 of process capability. So in the selective assembly, what you do, you divide the process capability range into 4 parts. First part, second part, first, second, third, and fourth. We are dividing into subgroup, so that within the subgroup, variation in the dimensions is exactly equal to the desired tolerance. So this procedure is called selective assembly. Okay. So generally, whenever we say tolerances, this is the grade of tolerance. So whatever tolerances we have arranged, including the tolerance sink, it is this tolerance. Okay, na? Now, suppose the tolerance is the entire normal distribution. Then what to do? Tolerance is the entire normal distribution, then what to do? Your overall length, this is one normal distribution. Oh, change color, it will be better. This is another normal distribution. This is another normal distribution. So there are 3 normal distributions. Now, overall length will be another normal distribution. Overall length will be another normal distribution. Let us say sigma 1 is the standard deviation of this normal distribution. Sigma 2 is the standard deviation of this normal distribution. Sigma 3 is the standard deviation of this normal distribution. Suppose the 3 normal distributions are arranged in this way. What will be the normal distribution of the overall length? It will be sigma will be under root sigma 1 square plus sigma 2 square plus sigma 3 square. Any multiplication and division will be common, and it will be common here also. So here I can calculate the same thing may be valid for tolerance here. So tolerance wise, if you see, it will be 1.2 square plus 1 square plus 1.5 square. Technically speaking, this is 6 sigma, na? 6 sigma 1, 6 sigma 2, 6 sigma 3. That's the way we do it. So now calculate the overall tolerance of the overall length, and this is coming out to be 2.16. 2.16, and the overall length will be 65. Basic size will be 65. So answer will be A, because entire length is the normal distribution. Entire length is the normal distribution. Entire length will be the normal distribution. So when these type of questions are given to you, that entire segment is the normal distribution, you are preparing separately and joining them, what you should do, you should calculate the tolerance of the overall length by this procedure. And basic size, you stack up one after another. So answer will be A. So this procedure I want you to teach you. That is the reason I have gone in the background of even the normal this one, process capability and selective assembly. Generally, whatever tolerance we deal with in metrology, it is this tolerance. This is the entire probability. It's a portion of probability of normal distribution. But in this question, it's the entire normal distribution. It is the entire normal distribution. So everybody understood how to handle such problems? Please let me know in the chat box. How basic size came 65? 18 plus 32 plus 24. 18 plus 32 plus 24 will be equal to 65. That's how the basic size came. Okay? So let me know whether everybody understood or no. Everybody understood this question, how to handle it? Please let me know in the chat box. Whether everybody understood this question, please let me know in the chat box. If everybody understood, then I will move forward. Let me know in the chat box whether everybody understood. Not coming 65? आना चाहिए, आना चाहिए. 30, 40, 50, 60, 74 आ गई. Oh, maybe there is some. Oh, I see. Anyway, okay, na? 18, 32, 20, maybe some basic size, but that is the way we will calculate tolerances. Okay, na? Maybe there is some error here somewhere. We have made a mistake. 30, 40, 50, 60. 30, 40, 50. I don't know. There maybe we made some mistakes. Okay, na? Yeah. Oh, sorry. It is a 74. It should come. Anyway. So anyway, basic size 74. Okay, na? Basic size is 74. Okay, all right. ठीक है, basic size is 74. But concept was tolerance. Tolerance, okay na? Yeah, tolerance. Whether everybody understood the procedure how to handle the tolerances, that will let me know. Seeing the option, okay, all right, okay, all right. Concept how to calculate the tolerances should be clear. If that is clear, we can move forward. If that is clear, we can move forward. Yeah, very good. Some more people can tell me in the chat box whether everything is clear. Okay. Some more people can tell whether everything is clear. Very good, very good. All right. See this question. See this question. अरे आदमी है ना, तो आदमी मिस्टेक करता है कभी कभी कैलकुलेशन में, तो दैट इज द रीजन आई टॉल ऑलवेज दिस इज माय कैलकुलेशन और आवर colleagues calculation. Your calculation can be different. Okay na? So because it's a multiple view na. Okay. अरे काहे को इतना परेशान हो रहे हो, टेस्ट सीरीज पे हम वी विल कम्युनिकेट इन द टेलीग्राम चैनल. अरे भैया ज्यादा परेशान मत हो जॉन फिलिप, टेस्ट सीरीज आ जाएगी, वी विल लेट यू नो in the telegram channel. Question number 13. In an interchangeable assembly, shaft of size this is a shaft, and the hole size is here. The maximum interference in microns in the assembly is, give me the answer quickly. 1 minute, I want the answer. Yeah, you are correct. You are correct. Vishal Kushwaha. Variance, no, variance is basically sigma square. Sigma square is called variance. See, if you have this doubt, now metrology, in the first lecture, I teach all this normal distribution for 2-3 hours. So during that time, I generally clear, but in the crash course and Abhyas, we have not taken that approach. Okay, all right. Quickly, I want already some answers are there, suggested answers. So, shaft is this. Shaft lower 0.01 and upper is 0.04. Make the fit diagram. Make the fit diagram. Things will be clear. And the hole is both positive. Hole is both positive. Lower is 0.02. So this will be the hole. 0.03. Ayo. This is 0.04. And this is 0.03. Oh, little tricky question. Huh? If you don't make the fit diagram, you will be thoroughly confused. 0.02 and this is 0.03 and this is your hole. Now, this is the complete fit diagram now. This is the complete fit diagram. So what is the maximum interference? What is the maximum interference? What type of fit it is? Tell me. What type of fit it is? What type of fit it is? Can you tell me in the chat box? What type of fit it is? What type of fit it is? Alright, tell me in the chat box what type of fit it is before giving me the answer. Before giving me the answer, what type of fit it is? Yeah. Yeah, transition, very good. Very good. It's a transition fit. Transition fit, very, very good. So what definition of transition? What is the definition of transition fit? If there is an overlap in the tolerance zones, if there is an overlap in the tolerance zone, it is called transition fit. Very good. If it is an overlap in the tolerance zone, it is called transition fit. So How we have to calculate the interference? Color change to, let us say, this. So when the interference will happen? When we take the maximum size of shaft and minimum size of hole. This is called interference. So minimum size of hole and maximum size of shaft will lead to the interference. So this is 0.04, this is 0.02. So this comes out to be 0.02 mm and 0.02 mm is 20 microns. Answer is C. See, answer was correct. For most of you, answer was correct. Hare Suresh Banod, how it is interference fit? Ayyo Rama, how it is interference fit? Tell me. Hare, it's a transition fit, na? Yeah, Duvedi, correct. Transition means sometime clearance, sometime interference. Transition means sometime clearance, sometime interference. It's called transition fit. Banot. Huh? How it can be interference fit? See the diagram, na? How it can be interference fit? User intelligence little bit. Okay, na? Very good, very good. Answer C. Most of you are giving the correct answer. Shall I move forward? Okay, na? So most of the questions today we are dealing is easy. Most of the questions we are dealing with easy. Transition fit means sometime clearance and sometime interference. Transition means sometime clearance and sometimes interference. Yeah. See the question 14. 1 minute I will keep quiet. You give me the answer. Use your mind. Don't give the answer in rush. You please use your mind. Don't give me answer in rush. Please do not answer rashly. The purpose of Abhyas batch is to train you to control your mind, and with the level head, you should be able in a position to hit the answer. Not rash. Do not rash. Rash driving, eh? We say rash driving, na? So don't do rash driving. Please don't do rash driving. Okay, na? Because rash driving, there will be accidents. And what is the accident? Rank fluctuation. Go and no go, because some of you are not following my first direction. What is my first direction? Make fit diagram. No matter how easy question is. No matter how much easy question is. हाँ, इंटरफेरेंस फिट में शाफ्ट ऊपर होगा. अरे बनोत, देखो, once again. Yeah, there is an interference, na? Banot, I think you are Telugu person. That's the reason I was speaking, communicating in that way. There is an overlap, na? When there is an overlap in the shaft and the hole tolerances, it is called transition. But when the shaft is completely above, that is called interference. For example, let us say this is a hole, and when the shaft is totally above, this is called interference. This is called interference. Okay, now? Okay, now. Yeah. We have to design go and no go for this shaft. So 36 is the basic size. This is your shaft. And this is 0.01. And this is 0.07. So this is 0.06. See, you observe me. What approach I am taking to solve questions. It will be easy for you in an exam. What approach I am buffering? How it? No, now it's clear. Now it's not buffering for me. Oh, actually, everybody. One student said buffering. Is that okay with everybody? because my system is okay now. Because the moment there is some issue, immediately on screen, I'm able to see some issue. But my screen is okay now. Okay, na? My screen is okay, so. All right. So see the sequence which I follow, making the fit diagram. Please follow that. The purpose of today's Abhyas batch is how to attempt limits, fits, tolerance, and gauge problems. Okay, now all right. So I'm making the fit diagram. It's a shaft. Okay, and then tolerances. Then the tolerances. Yeah, tolerances. Shaft it goes down. This will be go. This will be not go. One more thing I would like to tell all of you. One more thing I would like to tell all of you. That in exam, when the type of gauge is not given to you, in exam, when the type of gauge is not given to you, design ISO gauge. No workshop, no inspection. Either when the type of gauge will be given to you, because here of course it says ISO system. Here it says you have to say ISO system, but sometime it is not given. The which type of gauge you have to design, ISO will not be mentioned. So in that situation, design ISO like this one. Okay, na? So, but here there is a difference given in the problem. Gauge tolerances are taken as only 5% of the whole tolerance. Gauge tolerance will be 5%, means 0.05, and how much is the whole tolerance? 0.06. So comes out to be 0.003. Generally by default we take 10%, na? Book says 10%, but once again, do not follow that blindly. Sometime in the question, gauge tolerance may be different. You have to take that. 10% is not a universal standard. Whatever question says, we have to follow according to that. So 0.003. So 0.003 here. 0.003 here. See, in this question, I have not taken wear allowance. In this question, I have not taken wear allowance because work tolerance is less than 0.1. So I have not taken wear allowance. That's the reason I have not taken the wear allowance. But if it is given in the question, I have to definitely take. If it is given in the question, I have to definitely take. Now, can you give me the answer? The respective sizes of go and no-go gauges. Respective sizes of go and no-go gauges. But you know what some of you will say? Everybody should hear me now. For 1 minute, everybody should hear me. Some of you will say, "Arey sir, go, there is a range. No go, there is a range. Go, there is a range. No go, there is a range." So, which size we have to give? Maximum size or minimum size? No go, minimum, maximum size or minimum size? I will give that size. This concept I have also explained to you during your crash course. I will give that size which includes the gauge tolerance. Once again, hear very carefully. Once again, hear very, very carefully. In the answer of gauge design, if only one option has to be given, one dimension of go and one dimension no go, you have to give that dimension you have to give that dimension which includes the gauge tolerance. For example, here give this size of go and this size of no go. So no go gauge will be 36 plus 0.0 plus 0.01 minus 0.003, correct na? 36 plus 0.0 minus 0.003. So how much it comes out to be? 36.0. You tell me. 0.003, 36.0. Our, framing the answer be, and anyway, 007. This is your shaft, not a hole. Okay, anyway. And for go, it will be 36 plus 0.07 minus 0.003. So comes out to be 36.067. So answer is not matching, out of any of these answer is not matching. The reason is, here we have said shaft, but technically speaking, they have calculated for hole. Anyway, okay, na? Because while framing the question, sometimes the error happens. Okay, na? If it is a hole, the answer will match. If it is a hole, answer will match. I will make the hole. Let us say 36 and 0.06, 0.06, 0.01, and because it is a hole, this is the go and this is the not go, and same thing I'm making for hole. 0.003, 0.003, correct na? Exactly same thing. 0.0, I'm making it exactly the same thing. So, but it's for hole. This the go, this the not go. Now, what is the size of go? 36 plus 0.01 plus 0.003 comes out to be 36.013. Okay, na? And for not go will be 36 plus 0.07 plus 0.003. 36.073. This. हेलो हेलो, अब ये नेट तो सही है, इसमें बफरिंग कैसे हो गई? इसमें नेट तो सही आ रहा है, पर बफरिंग कैसे हो रही है? मेरा नेट तो करेक्ट है पूरा। हाँ, चेक करो जल्दी से, क्योंकि एक्चुअली वो बंद हो गया पूरा, बफरिंग हो रही है। हाँ, पर नेट स्पीड करेक्ट है, 320 Mbps। Okay. I think again we are, see, net was okay. Can you just now confirm with me whether everything is okay? There, the software with which we are speaking. हाँ, अब आ गया लग रहा है. क्या हो गया एक्चुअली, बीच में क्या हो गया था ये? Net to 320 Mbps. Anyway, it's live. Okay, we will talk later. Okay. Okay. Now, can everybody confirm that everything is okay? Please confirm whether everything is okay. All right. There were some, I think, OBS related issues. Anyway, I don't want to waste time here. Okay, now everything is okay. Set. Question number 15. So this question, read carefully. Please read carefully. And give me the answer. Question number 15. Please read it carefully and give me the answer. In interference fit, the outer diameter of the inner cylinder, interference fit, all of you understand. What is the interference fit? It's a hole and this is the shaft. If you are getting any confusion, please make it. Please draw and then do it. Interference with the outer diameter. So when the shrink fits, हाँ, ये क्या हो रहा है जी? हेलो, हेलो, आवाज नहीं आ रही आपकी. आज ये क्या हो रहा है? ये तो 320 Mbps दिखा रहा है. नहीं, वाईफाई नहीं, लैन. ये लैन है, पूरी लैन है एक्चुअली. दिखा दे. नहीं, लैन है, लैन पूरी. और तो क्लास 15 मिनट खत्म होने वाली लेक्चर ना. हाँ, मैं 15 मिनट मत करूँ, लेक्चर खत्म ही कर लेते हैं अभी पहले, है ना. 15 मिनट में हो जाएगा खत्म. ओके, हाँ, एक मिनट. हाँ, sorry, I don't know why it is happening today. So we will. Okay, I think we are again live. Today there is some issue. After class we will see something. Okay, na 10 minutes. I want to finish 10-15 minutes. So now today I don't know why this happening. Already so many classes I have done. It's a shrink fit. The way we do it, outer cylinder will heat, so it will expand. Put it on the another cylinder and then shrink. And then shrink. It's a shrink fit. So when I will be adopting this, when I don't have to dismantle again and again. Because again, if you want to disassemble it, again you have to hit it. So statement 2 is wrong. Statement 1 is correct. Answer is a C. Answer is C. Everybody is okay now? Yeah, everything is fine. Okay, everything is fine now. Now question number 16. These are easy questions, but I want your mind muscles to be strengthened. I want the muscle of your mind to be strengthened. See question number 16. These are easy things. Let me know what is the answer. Question number 16. I'm standing on the side so that you can read the problem properly. Okay. In an interference fit, once again interference fit, The moment interference fit comes, the fit diagram should come to your mind. Between a shaft and a hub, the state of stress in the shaft due to interference fit. Due to interference fit. Yeah, tell me. Now, the way it happens, in strength of materials, our team is going to teach you, take this topic to a great level. This is the shaft. Now, cylinder, this portion, red one, na? You are going to heat, so it will expand. The moment you put it over it, it will press the shaft. You know why we do it? To introduce compressive hoop stresses. The way we do it, to introduce compressive hoop stresses in the inner shaft. That's why we do it. Okay? In an interference fit between the shaft and a hub, this is the shrink fit. Shrink fit. Last problem. But if it is a normal problem, shaft, hole, we hit it, so that it goes in it. If we are not heating, compressive hoop stresses will not come. So, hole, shaft, hit it, so that shaft entirely goes into it. It's called force fit. In that force fit, only the compressive radial stresses will come. This compressive hoop stresses, when it will come? In the shrink fit. Last, problem number 15. Problem number 15, if it is a shrink fit, like heating and then cooling it, compressive hoop stresses will also add up. Suppose if I modify this problem, shrink fit, interference, shrink fit. Suppose if I modify this problem, shrink fit, so answer will be compressive radial and the hoop stresses. That will be the answer. So understand, by the changing here and there, how the option changes. But if the shrink fit is not there, I will put only answer A. If the shrink fit is not there, I will put answer only A. Okay, na? So slight changes, answer will also change. Now, next. Yeah, 17. Because I want to, because I don't know when the problem is going to start. Okay, buffering, I don't know how it's coming today. We have done already 23, 24 classes. Okay. Consider the following statements. Read the problem carefully and try to give me the answer. In case of assembly of mating parts, the difference between hole size and shaft size is called, this is the P by Q. This is another P by Q. Can you give me the correct answer here? Yeah, Ashok Dahi, it is a forced fit. Can you give me the answer of 17? Can you give me the answer of 17, please? Can you give me the answer of 17, please? Yeah, oh my God, very good, very good. Tejeshwar, Mothukuri, Vishal, Pavan, very good, very good. The difference between hole size and shaft size is called allowance. See, in metrology, there is nothing called hole size, nothing called shaft size. In metrology, there is nothing called hole size and nothing called shaft size. It is always a tolerance. We call it basic size and tolerance. So first statement is wrong. In transition fit, a small positive or negative clearances between, very good. This is the correct statement. Negative clearance is called interference. Negative clearance is called interference. Positive clearance is called clearance. Negative clearance is called interference. So, what is the transition fit? Sometimes there is a clearance and sometimes there is an interference. The second statement is correct. See, Here everybody hit the correct answer. Here everybody hit the correct answer. So I'm very happy. Read the options very, very carefully before hitting the answer. Yeah. See this one? Let me know which answer you will hit. Interference fit joints are provided for. Tell me. Interference fit joints are provided for assembling bush bearing to housing. If there is no interference fit, there will be play between the hole and shaft. Very good. All of you are giving the correct answer. Mounting heavy duty gears on the shaft, no. Generally, when the heavy duty gears are mounted, by fastening and all that, we clamp it. It's never interference fit. Mounting pulley over the shaft, is not a interference fit. In the villages we see pulley over the motor drawing the valve, it's never interference fit. Assembly of flywheel on the shaft, that is also, if you see the flywheels and all that, there are fasteners inside, we tied it from all the side. So among all these things, yeah, you are correct, key gears are used. If there is a very big flywheel, there's a key to fasten it, so it's a A. Very good champions, very good champions. 18th, let us say 19th. This problem we did during the crash course also. So similar problems. The tolerance of X, this tolerance is 20 plus minus 0.03, 20, sorry, not like this, 20 plus minus 0.3, and this is 50 plus minus 0.5. What is the tolerance of this? Such problems we did in Abhyas. I am going to tell you the shortcut only. I will tell you the shortcut only, not the long cut that we discussed in crash course. So X is, let us say, this is A, this is the B. So X is A minus B. Can I do that? A minus B is X. So upper limit and lower limit, keep it separately. 50 minus 0.5 plus 0.5 minus B is 20 minus 0.3 plus 0.3. Okay, na? So X, 50 minus 20, 30 is the basic size. We do cross addition. Of course, it's an easy problem, but I want to go through procedure. Suppose some new problem appears. That is the reason I want to go through the procedure. Cross addition, plus 0.5 minus 0.3. And then cross addition here, minus 0.5 minus plus 0.3. So X is 30 minus plus minus 0.8 D. Kindly remember this shortcut. Of course, answer everybody will be able to hit, but please remember this shortcut. It's a very important thing, and this thing is going to help you a lot in GATE exam. Because if you see 4 or 5 years back, a lot of problems used to appear from this tolerancing. This topic name is tolerancing. Tolerancing. And kindly remember this shortcut. Kindly remember this shortcut. Okay, na? Okay, everybody's okay? So practically everybody given the correct answer. So that is the reason I will move forward. Okay, give me the answer for this. Pick the wrong statement about Taylor's principle of gauging. Out of this 4, one statement is wrong. Taylor has given 2 statements about the gauge design. Na? Taylor given 2 statements about the gauge design. Out of these three, out of these four, one statement is wrong. Can you identify that wrong statement? Can you identify the wrong statement? Can you identify the wrong statement? See, let us see who is the champion here. It's a very good problem. Okay. So, go gauges should be full form gauges. It's a correct statement. You know what is the meaning of full form? It's a go gauge. It's a go gauge full form means full working length. The length of go gauge should be more than the length of hole. Length of go gauge should be more than the length of hole because it has to check the size as well as shape. It has to check the size as well as shape. So full form. I hope you are correct. So first statement is 100% correct. Option A is 100% correct. B, go gauge should check all the related dimensions simultaneously because it has to check size and shape. You know, there was one question in GATE that, go gauge check size and shape. So some faculty teaches only size, no shape. And wrong. It has to check the shape. Suppose there is a taper inside the hole, it has to check that also. Go gauges are used to check size as well as shape. So second statement is also correct. All related dimensions simultaneously because it has to cover the entire working length. Because it has to cover the entire working length. It is sufficient to use go gauges on the width and the length of the component. No. Suppose it's a square. We have to use no go gauge also, no? Go gauges alone are not sufficient. Not go, generally we say no go. It's not go, no go. Gauges should be checked only one dimension at a time. You know what is the meaning of that? What is the meaning of checking one dimension at a time? So wrong statement is C. I will tell you what is the meaning of fourth statement. What is the meaning of fourth statement? Suppose you have drilled a hole by using a drill, and because of some error in machining, the hole is slightly oval. After drilling, the hole is slightly oval, but this ovality you are not able to see from your naked eyes. So no-go gauges are in this shape. No-go gauges are in this shape. So no-go gauges are used to check one element at a time, meaning no-go gauge, one element like this, not going, this not going, not going, not going. If it is oval, along this axis it will go. So one element at a time is ovality, minor axis not going, not going, not going, but along major axis it will go. At multiple position, at one position if it goes, it means the hole is oval. So no-go gauges are used to check one element at a time. That's the meaning. So C statement is wrong here. C statement is wrong here. Okay, now very good. Some of you already hit the bull's eye before I give the answer. Last question for the day. Last question for the day. Read it and then give me the correct answer. Read it and give me the correct answer. The statement that best describes the function of a go gauge in the context of Taylor's principle of gauging. Go gauge. What is, oh sorry, change color. Go gauge. in the context of Taylor's principle of gauging. Can you give me the correct answer? Read it. This is the last problem for the day. In the last problem, I have explained about the Taylor's principle a little bit. Arey, very good. Pavan Dwivedi, you are a champion. Noora Fatehi, Tejaswar Motukuri, Rohit Gupta, Raj, all the champions are giving the answer. Okay. So, very good, very good. Go gauges checks the go gauges are designed at maximum material limit, and it is designed to check many dimensions as possible, because not only size, shape also. 100% correct. Go gauge checks the least no, not least material. So B statement is wrong. Very good. All of you are champions, really. All of you are champions. Go gauge checks the maximum material limit condition designed to check only one dimension. No, many, size as well as shape. Go gauge check the least. Oh, no. So only A is correct. Very good. All of you did really very well. That was today's lecture. In the today's Abhyas lecture, we have discussed some of the theoretical and numerical problems on limits, fits, tolerances, and the gauge design. Saturday, Sunday generally is not Abhyas classes. Monday in metrology, we are going to discuss surface finish, screw thread metrology, interferometry, and some other theoretical questions of the remaining topics. So Monday lecture is going to be interesting. Tuesday I will discuss welding, and Wednesday will be automation. 2nd November will be automation. And after Abhyas, I will be very much active on the Telegram channel and discussing your doubts on a one-to-one level. So thank you very much. Today was little problem because of some issues, buffering and all that. But anyway, see you on Monday. Good afternoon to everyone. Good afternoon to everyone. Thank you very much. See you on Monday, 11 o'clock.